Welcome back to part 2 for lesson 2.6. We've already gone through most of the lesson. This is just a few extra problems that we didn't cover for review of what the content. So we're working on absolute value equations and reminding ourselves that whatever this expression on the inside of the absolute value equals, it can either equal a 10 or a negative 10. And after it goes through the absolute value machine, a 10 will come out. So we can say that 2 minus 3 1/3 a equals a negative 10, or 2 minus 1/3 a equals a positive 10. And then first thing we're going to do is eliminate the fractions. So if we multiply through by this denominator of 3, we'll have 6 minus a equals a negative 30 on the left, in the left equation here. And so we're going to subtract 6 to get all of our constants to one side. And then dividing by negative 1, we get a equals 36. We're going to multiply this equation by 3 as well to eliminate the fractions. Very similar to the left equation, 6 minus a equals a positive 30. So again, we're going to subtract 6 and divide by a negative 1, and we get a equals a negative 24. And we said that we can see this also in Desmos. If we put the left-hand side equal to y, so y equals the absolute value of 2 minus 1/3 x. We have to use x instead of a. And then we also do y equals the right-hand side of the equation, so have it equal to 10. Then we can scroll out because we have to get to where y equals 10. So if we scroll out, you can do that by zooming on the right here. You can zoom in and out. And if you click on the equations, it will show you where they equal. So they equal at a positive 36 and they equal at a negative 24, just like we had shown. So I encourage you to do this each time just to check to see what you're getting. And then we can show it with our algebra. So let's go back here to H. So H has an additional step. We have to isolate the absolute value first by subtracting 4. And then we'll have the absolute value of 5x minus 3 equals a negative 1. And before we even go to put it in the calculator, we can, or Desmos, we can validate that an absolute value will never equal 1. So here's our absolute value function. And a negative 1 is down here. So this answer is an empty set. This absolute value will never come down and touch a negative 1. Okay, letter I. Again, we have to add, isolate the absolute value by subtracting 2. So we have the absolute value of 2p minus 6 equals 8. And so 2p minus 6 can equal a negative 8, or 2p minus 6 can equal a positive 8. So to solve for p, we're going to add 6 to both sides, and then divide by 2, and we get p is equal to a negative 1, or having 6 and dividing by 2, p equals a positive 7. Then we had 3 at the end of the lesson that we didn't get to. So now this was the extension that we talked about, where we have an absolute value equal to another absolute value. So it's equal to the positive and equal to the opposite. So 5x minus 8 equals 5x plus 8, or 5x minus 8 equals the opposite of 5x plus 8. So the set of equations on the left, if we want to solve for this, I'm gonna put my x's on the left. And so the x's completely cancel, and we're left with a negative 8 equals 8, which cannot be, so that's not true. There's no solution there. And then over here, it's going to be 5x minus 8, distributing the negative. We arrive here. So if we add 5x to both sides, we get 10x minus 8 equals minus 8. And then we're going to add 8 to both sides. We get 10x equals 0. And dividing by 10, we get x equals 0. So let's go ahead and just look at this one in Desmos. This is be good practice for us. Turn these off here. So we're going to do y equals the absolute value of 5x minus 8, and then y equals the absolute value of 5x plus 8. Oops. Put that in the wrong spot. Okay. And so we're going to zoom, and we're going to see that the only time that they equal is at x equals 0, just like we had found in our paper. It's a pretty picture, though. Okay. So let's look at letter D. The letter D is going to be 0.07 minus 0.01x equals 0.08 minus 0.02x, or 0.07 minus 0.01x equals the opposite of 0.08 minus 0.02x. Parentheses. We have to distribute through the negative. So let's solve the equation on the left. So I'm going to multiply through by 100 to eliminate these terms here. So when I multiply by 100, I will have 7 minus 1x equals 8 minus 2x. That makes it much easier to work with. Then we're going to add 2x to both sides. So we'll have 7 plus x equals 8. And we're going to subtract 7. And we'll have, it looks like x equals 1 is the solution on this side. Now, likewise, I'm going to multiply through by 100. So I'll have 7 minus 1x equals, and this is a negative, so it'll be a negative 8 plus, because a negative multiplied here, 2x. Distributing the negative because we had to do the same equals the opposite. Now again, I'm going to get my x's to the left, but this time I'm subtracting 2x. So we have 7 minus 3x equals a negative 8. And subtracting 7, we get a negative 3x equals a negative 15. Dividing by a negative 3, we land on x equals a positive 5. So those are my two solutions, x equals 1 and x equals 5. And one more for practice, if you're staying with me here, we're going to do the same, or the same equals the opposite. So x minus 4 equals 4 minus x, or x minus 4 equals the opposite of 4 minus x. So on this side, I'm going to add x to both sides. So it looks like I have 2x minus 4 equals 4. Then I'm going to add 4 to isolate x here. And dividing by the 2, we get x equals 4. Then on the right, I'm going to distribute through the negative. And then I'm going to subtract x to move them to the left. But what happens is both x's cancel. And we get a negative 4 equals a negative 4, which would mean all real solutions. So let's go ahead and put this in Desmos just so we can be sure that this makes sense. So this is x minus 4. And the other one was 4 minus x. And indeed, it does look, so there they are. They're overlaying each other. So if I turn off the purple, the green is still there. If I turn off the green, the purple is still there. So in that case, the answer is all real numbers. And that means we can, this R with a double line through it is a solution, or you can say a negative infinity to infinity, because any of those values will make this statement true. So that concludes the second part for lesson 2.6 on absolute value equations. Catch me back for lessons in 2.7.